We tend to think of our skeleton as just a static frame, right? Like scaffolding. But that's not the whole story, not even close. Deep inside your bones, there's this constant process of breaking down and rebuilding happening right now. So today, we're going to go inside this incredible living structure. We're going to see how it's not just holding you up, but how it's also creating your blood and responding to every single move you make. Let's get into it. So how in the world can our bones be a blood-producing factory, a fortress protecting our most delicate organs, and a mineral bank all at the same time? It sounds like a lot for one system to handle. Well, that's the puzzle we're piecing together today. We're going to explore the absolutely brilliant design of our bones and cartilage that makes all of this possible. All right, first up, let's get the lay of the land. We're starting with the big picture, the complete skeletal system. This is the fundamental architecture that, makes us who we are. So the way we look at it is by splitting this whole framework into two main zones. First, you've got the axial skeleton. Think of this as your core, the central pillar running right down your middle, so your skull, your spine, and your ribs. Then everything else, your arms, your legs, your shoulders, that's all part of the appendicular skeleton. Basically, all the appendages that hang off that central axis. And this system is doing so much more than just holding you upright. Yeah, it gives our muscles something to pull on so we can move. And sure, it's a protective cage for our organs. But here's where it gets really amazing. It's also a mineral bank, constantly storing and releasing calcium. And deep inside, the marrow is a nonstop blood factory. It even affects the sound of your voice. So you see, it's not just a scaffold. It's a dynamic, living organ system. Okay, let's zoom in a little. We're going from the entire system down to the individual building blocks. We're about to look at the different blueprints our body uses to build bones for very specific jobs. And this is a perfect example of form following function. Long bones, like the femur in your leg, are these incredible, powerful levers. The short, blocky bones in your wrist, they allow for all those intricate, delicate movements. You've got flat bones, like your shoulder blade, that provide a wide surface for muscles to attach to. And the super complex shape of your vertebrae, it's custom designed to protect your spinal cord. Every single bone is a piece of specialized engineering. So let's break down a typical long bone. The main shaft, that's the diaphysis. Think of it as the long central pillar of the bone. This is its structural core, and it's actually hollowed out to hold that precious bone marrow we were talking about. Now, at either end of that shaft, you have the epiphysis. These are the expanded ends, and they're perfectly shaped to connect with other bones. This is what forms our smooth, gliding joints that let us move. And sandwiched right between the shaft and the ends is the metaphysis. Now, this small region is where all the magic happens when we're growing up. It contains the growth plate, which is literally the engine that lengthens our bones as we grow from a kid into an adult. Okay, time to go even deeper. Let's get out the microscope and go past what the eye can see. We're going to explore the internal architecture that gives bone its incredible properties. This is just a brilliant piece of natural engineering. The outer layer is dense, compact bone, which gives it incredible strength to resist pressure. But inside, it's a totally different story. We find this spongy, kind of honeycomb-like bone. This provides all the strength it needs, but without adding a ton of weight. It is the absolute perfect balance of durability and lightness. Now, this next part is one of the most incredible facts about our skeleton. It's not a finished product. It's alive. And it is constantly remodeling itself based on how we live our lives day in and day out. And this whole concept is captured perfectly by something called Wolff's Law. It simply states that bone adapts to the load it's placed under. So the more mechanical stress you put on a bone, say from running or lifting weights, the more your body responds by making that bone denser and stronger. It's literally a use it or lose it system in its purest form. And to do all this constant work, remodeling, creating blood, healing itself, bone needs a serious blood supply. It's not some dry stick, it's a living organ, and it's fed by this complex plumbing network of arteries. You've got major arteries that feed the core and the marrow, while other specialized vessels supply the ends, the growth zones, and even the outer skin of the bone. This is a highly active, hungry, metabolic tissue. So, what do we call the process of building all this bone? It's called ossification. You can think of it like a sculpture that's being slowly hardened. It all starts from these very specific points where the body begins to lay down minerals, and it gradually turns a soft, flexible model into hard, rigid bone. But you know what? Bone isn't working solo.
It has an essential partner that's just as vital for our movement and our structure, and that's cartilage. Let's take a look at how this flexible tissue completes our skeletal system.
Cartilage is a truly unique tissue. It's firm, but also incredibly elastic. But here's the really wild part. It has no direct blood supply. None. It gets all its nutrients through a slow process of diffusion, which is exactly why a cartilage injury can take so painfully long to heal. And just like bone, cartilage isn't a one-size-fits-all deal. You've got hyaline cartilage, which is the super smooth, glassy surface on our joints that lets them glide effortlessly. Then there's fibrocartilage, which is packed with tough collagen, making it the perfect shock absorber in our spine. And of course, elastic cartilage, like in your ear. You can feel it right now. It can bend and snap right back into shape. So we end where we started, with this idea of a living, adaptable skeleton. Knowing that our bones are a direct reflection of our actions, of the stresses we put on them, it leaves us with a really powerful question. What choices are you making today that are building the strong, resilient framework you're going to need for all of your tomorrows?